I said, and you know that from Pythagoras theorem that hypotenuse square is equal to opposite squares plus adjacent square. And I also told you that you can derive as many Pythagorean triplets as possible. You can take one of the Pythagorean triplet as an odd number and you can derive any number of Pythagorean triplet. For example, if I take the Pythagorean triplet as 7, which is an odd number, how to find the other two values in this triplet? 7 square is 49. Divide this 49 by 2, you will get 24.5. Subtract 0.5 from 24.5. 24.5 minus 0.5 is 24. Similarly, add 0.5 from this 24.5. 24.5 plus 0.5 is 25. That means these three values 7, 24 and 25, they form a Pythagorean triplet, right? 7, 24 and 25, they form a Pythagorean triplet. Kindly refresh the page, sir, if it is offline. Similarly, if I have one of the values in my triplet as an even number, for example 8, square it. 8 square is 64. Divide the 64 by 4 because I am taking an even number. Divide it by 4. If I divide by 4, 64 by 4 is 16. Subtract 1. Don't subtract 0.5. 16 minus 1 is 15. Add 1. 16 plus 1 is 17. So this 8 and 15 and 17, these three will again form a Pythagorean triplet. You take an odd number or you take an even number. It is very easy for us to find the Pythagorean triplets. Do not by heart the Pythagorean triplets, which you cannot do it, because there are not only 1 or 2 or 3 or 4 Pythagorean triplets, there are infinitely many Pythagorean triplets. Use the logic of odd number or an even number and derive it whenever it is required for our examination point of view. This is one thing which we have learnt. I will be very briefly explaining whatever we have discussed yesterday. And if I come to the coordinate geometry, first quadrant is, it is 0 to 90 degrees. Second quadrant is 91 to 180 degrees. Third is 181 to 270 degrees. And the last quadrant is 271 to 360 degrees. And you already know that in these 4 quadrants, which are all positive, can I say that this first quadrant is, it is 0 plus theta. I explained you in detail in yesterday's class, sir. Or it can also be called as 90 minus theta, or it can also be called as 360 plus theta, because my base value in my first quadrant, I will start with 0 degrees or 360 degrees. Similarly, second quadrant, my base is 90 degrees. So this is 90 plus theta, or it is 180 minus theta. All these things are very in detail explained in yesterday's class. Third quadrant, my base value is 270 degrees. So this is 270 minus theta, or it can also be called as 180 plus theta, right? 180 plus theta. Similarly, fourth quadrant, it is also called as 270 plus theta, or it is 360 minus theta, or I can also call the 360 as 0 degrees. It is 0 minus theta, right? It is 0 minus theta. The other thing which we learned from this quadrant is, in first quadrant all the trigonometric functions are positives. A represents all. In second quadrant, sine and its reciprocal cosecant are positive, so it is yes. In third quadrant, tan and its reciprocal secant are, tan and its reciprocal cot are positive. In the last quadrant, cosine and its reciprocal secant are positive. And I explained you why all are positive in first quadrant, why only sine and cosecant are positive in second quadrant, why tan and cot are positive in third quadrant, and also why cos and secant are positive in fourth quadrant. In detail we have explained in yesterday's class, so that our conceptual clarity should be very clear, sir, right? It should be very clear. And we also learnt another concept saying that, can I say that, suppose for example I have sin theta. This also we learnt yesterday in detail with conceptual clarity we learnt. Suppose I have sin theta. If I want to convert sin in terms of cos, write down cos and write it as 90 minus theta. Write down cos and write it as 90 minus theta. Similarly, suppose if I want to find tan theta, if I have tan theta, if I want to express tan in terms of cot, tan theta is nothing but cot of 90 minus theta. That means, can I say that if it is 90 plus or minus theta, or if it is 270 plus or minus theta, my trigonometric functions will definitely change. What all it will change to? Sine will become cos, and similarly reverse, cos will become sine, tan will become cot, and the reverse of tan is cot is nothing but tan, cot will become tan, and secant will become cosecant, cosecant will reversely become as secant, it will reverse and become it as secant. This is only if 90 plus or minus theta or 270 plus or minus theta is applied. Similarly, if 0 plus or minus theta or 180 plus or minus theta or 360 plus or minus theta, if any of these particular even multiples of 180 are present, then the trigonometric functions will not change. Then there is no change in our trigonometric function. You need not change any trigonometric functions and waste your time. You can keep the same trigonometric functions whatever is present. I hope the idea is clear, sir. Same trigonometric functions whatever is present, you can keep it. Now this is something which I did not discuss in yesterday's class. Now listen carefully, sir. Suppose, can I say that, can I say like this? Think logically. Can I say as, suppose I want to find cos of minus theta, right? Cos of minus theta. Cos of minus theta can also be written as cos of 0 minus theta. 0 minus theta is nothing but minus theta itself. Now 0 minus theta, 0 minus theta comes in which quadrant? 0 minus theta comes in fourth quadrant. In fourth quadrant, which two trigonometric functions are positive? Cos and secant are positive, and here also the trigonometric function which is given is cos. That means cos of 0 minus theta or cos of minus theta is also nothing but plus cos theta, right? Some of the students might note the property that cos of minus theta is nothing but cos theta, but I want you to know why cos of minus theta is nothing but plus cos theta, right? That is what I am more interested with. Similarly, can I also say that sine of minus theta, sine of minus theta is nothing but same logic. If I implement sine of 0 minus theta, 0 minus theta comes in fourth quadrant. In fourth quadrant, is sine positive? No, definitely sine is not positive in fourth quadrant. Sine is negative. So sine of minus theta is minus sine theta. Similarly, secant of minus theta, secant of minus theta is secant of 0 minus theta. Fourth quadrant, 0 minus theta is nothing but fourth quadrant. In fourth quadrant, cos and secant both are positive. That means secant of minus theta is plus secant theta, except cos and secant which are positive in fourth quadrant. Rest all will actually become negative, and those are the two values which will become positive, right? And after this, we have explained, we have understood so many other trigonometric identities which are called as transformation identities. One of the ways of transformation identities is converting from product to sum or difference. This is the first case.